Hello students, in this session we will solve few numericals related to the braking test. So in the braking test we will be determining what is the distance required for the vehicles to stop without colliding with the any obstructions. So now the sum of the relationship with respect to the braking test, we have the first relationship is it will gives you the relationship between the braking distance, coefficient of friction and the speed of the vehicle. So we have the equation L is equal to U square divided by 254 F. So if it is 254 F, here U is in terms of kmph, or you can also use U in terms of meter per seconds. So in that condition, the L relationship changes to L is equal to U square divided by 2GL. So where U is the initial speed of the vehicle. So you can take either in meter per second or kilometer per hour. Use the suitable relationship. And F is the coefficient of friction developed. So this coefficient of friction developed, either you can determine using the field test or the values will be given to you. And we have already discussed in the previous session for various type of the surface condition. Bituminous pavement surface will have different coefficient of friction. Similarly, concrete surface, earthen road. So each and every type of the road will have certain coefficient of friction. So IRC has recommended some value what should be the friction value developed by the various type of the pavement. So depending upon that, you can suitably assume the value of friction. So if you know any of two parameters, it is possible for us to determine the another known parameter. And also we need one of the relationship if F is not given to you, if F is unknown, we should be able to first find out what is the F. So that average skid resistance developed can be taken as given by F is equal to A by G. How did we got this? So you can look here, the frictional force developed will be equal to mass into the acceleration. So the frictional force, total frictional force is given by the weight into coefficient of friction. What we require? We require coefficient of friction F is equal to A by G. So anyways, we already discussed all these things in the previous session. So I'm just going to take the relationship F is equal to A by G. If value of F is not known and if they have given the acceleration value, you can take the value of, you can calculate the value of skid resistance developed. So next turn where G is the acceleration due to gravity and the value is taken as 9.81 meter per second square. And we require another few relationship. V is equal to U plus AT and V square minus U square is equal to 2AS. So this is a basic relationship that will gives you the initial this relationship between the initial speeds, final speed, acceleration and time. So here in this equation, U square minus U square 2AS, yes is nothing but equal to L, that is the braking distance. So now we'll look into the numerical. So first numerical says here that in the braking test is conducted, a vehicle traveling at a speed of 30 kmph. So this is the initial speed of the vehicle. It was stopped by applying a brakes fully and the skid marks were 5.8 meter in length. So determine the average skid resistance of the pavement. So now first we'll look what all the details given in the vehicle. Initial speed of the vehicle is given, U is equal to 30 kmph. It was stopped by applying a brakes and the skid marks were 5.8 meter in length. So skid marks is nothing but the braking distance is given as L. So determine average skid resistance of the pavement surface, that is F is need to be determined. So now whenever your problem is given to you, first analyze what conditions are given to you and what is the parameter that is required to calculate it. So now first write down the data given. Initial speed is given as 30 kmph. Convert it to meter per second, or else you can keep that also in kilometers per hour only. But since we are having length in meters, let us keep all the things in the same unit. Converting into the meter per second, we will get 30 divided by 3.6. Conversion for kilometer per hour to meter per second. So how did you got this value? So converting kilometer to meter, 30 into 1000 divided divided by 30 into 1000 divided by conversion from meter per hour to the second, so that will be equal to 60 into 60. So in short, 30 divided by 60 into 60 divided by 1000, so which will gives you 30 divided by 3.6. So this is how you can go for converting kilometer per hour to meter per second. So anyways, this steps is not required to do it each and every time. So directly you can take the value divided by 3.6, you can convert meter per hour, kilometer per hour to meter per second. So the next step is we should understand what is the relationship between the F, L, U. So we have only one relationship which is gives you the relationship between all the three parameters. So what is that relationship? Braking distance L is equal to U square divided by 2GF, or we have another formula, V square divided by 254 F. So anyways, the later formula will be used when the value of U is in terms of kmph. So since we have converted into the meter per second, use this relationship to determine the F value. So we know L value is given, U value is known to you, the only unknown G value you can take that as, so write down here only G is equal to 9.81 meter per second square. So substitute all the values. You can find out the only unknown here is the F value that can be determined. So next step is average skid resistance F is equal to U square divided by 2GL. I'm taking L into the denominator. So that is equal to 8. We will get the value of 0.61. So this is the average skid resistance developed by the pavement surface. Next numerical is, they have given a vehicle is traveling at a speed of 40 kmph and it will stop within 1.8 seconds after application of brakes. Determine the average skid resistance. So now first look what is the data given to you and what need to be determined. So initial speed of the vehicle U is given and the time required to stop the vehicle is given. We have to determine F, what is the value of F. So now which relationship you can use? So L is equal to U square divided by 2GF. We don't know what is the value of L and F is also unknown. We cannot use it. F is equal to A by G, another formula to determine the coefficient of friction. Here whereas the A is not given to you, this formula is also ruled out. So now first we should establish what is the, either the acceleration is need to be determined or the braking distances need to be determined. But we have a relationship V is equal to U plus AT. So which will gives you the relationship between initial speed, final speed, acceleration and time. For us the time value is given to us. So now like this you have to analyze the condition, what is given and what can be established. So to determine the friction value, either we should be knowing the braking distance or what is the acceleration. So you have to look into the other relationship which will gives you the relationship between the other unknown parameters. So now the initial speed is given and the time required is given to you, and final speed after the application of brake. So the final speed will be 0 always. Okay, so you even though if the problem in the problem final speed is not given, we can take the value of final speed as 0. So now the relationship which will gives you initial relationship between the initial speed, final speed and the time, and the acceleration can be done with the help of V is equal to U plus AT. So use this formula, determine what is the acceleration of the vehicle. So then you can substitute the acceleration in this relationship as F is equal to A by G. With the help with that we can determine what is the coefficient of friction, skid resistance or coefficient of friction developed. So first step is converting initial speed to meter per second. The value is given as 40 divided by 3.6. That will can be converted into the meter per second. We'll get 11.11 meter per second. And they have given the duration of brake application T is equal to 1.8 second. And next Yes, as I told you, we have the relationship v is equal to u plus at. The final speed can be taken as 0 and find out what is the acceleration of the vehicle. So substitute all the values, we will get 6.17 meter per second square. So now we can substitute the relationship between the friction, acceleration and the g value. F is equal to a by g. So with this you can determine the coefficient of friction, and we have got the value of around 0.83. So anyways, this is not required. You can directly take F is equal to a by g, substitute value of g is equal to 9.81 meter per second square, that is acceleration due to gravity. So you will get the value of friction as 0.83. And we'll move on to the next numerical. First we'll look into the data which is given. A vehicle is moving at a speed of 40 kmph. Yes, the initial speed value is given to you. At a stop by applying the brakes, and the skid marks was 12.2 meter. The value of L is given to you, that is 12.2 meter. If the skid resistance of the pavement is known to be 0.7, determine the brake efficiency of the test vehicle. So now for you, they have given the speed, skid marks. What is the skid marks that is formed? Skid marks measured was given, and also the friction value is given. So the average skid resistance of the pavement is known to be 0.7. Determine the braking efficiency of the test vehicle. So now with respect to the braking efficiency, I would like to tell you one thing. So the brake efficiency value will varies from 0 to 100%. Okay, so now the brake efficiency value is taken as 100%. The efficiency is 100%. When you apply the brake, if the vehicles come to stop immediately, the instant you apply the brake, if the vehicles comes to stop, then you can say that the brake efficiency is 100%. But what the brake efficiency, that will depends upon the coefficient of friction and the condition of the brake, and also the tire conditions of the tires, and also prevailing condition of the road surface, whether it is wet, dry. So all those things will affect the brake efficiency. So now here we want to measure the brake efficiency with respect to the friction value. And I've already mentioned you that the value of coefficient of friction varies between pavement surface. Bituminous pavement will have some value, concrete pavement will have certain friction value that is developed. So now here, initially when the road is constructed, when the new road is constructed, we will maintain the prescribed value of coefficient of friction, which is given by the IRC recommendation. So now here they have given that the particular pavement surface, the average skid resistance is what it has been designed is given as 0.7. But this 0.7 what we initially considered during the construction of the work, so this may not be same during the entire life of the pavement. So the value of friction will start reducing with the usage of the pavement. So because the aggregates will wear out, and there are various reasons why the coefficient of friction will start developing. So because we all know the newly constructed build, the good texture will be there. So when you take the condition of the tire also, so the new tires will have the good tires. When with the frequent usage, the tire get worn out. So similarly here the pavement also get worn out, and the coefficient of friction value will reduce us. Okay, so when the coefficient of friction value reduces in the pavement, the brake efficiency also reduces considerably. So now here we have to determine what is the brake efficiency of the test vehicle for the friction which has been developed with the condition of speed is equal to 40 kmph and the skid mark is 12.2 meter. So now for these two conditions, determine what is the actual friction of the pavement, and then compare it with the designed value, and you will get what is the brake efficiency. So now the first write down the data which is given to you. The speed value is given, u is equal to 40, initial speed as 40 kmph. The convert that, we will get the value as 11.11, and the braking distance is given, and if f, the design value of coefficient of friction, is given. So now for these two conditions, determine what is the actual skid resistance that is developed. So we know that can be taken as f dash is equal to u square divided by 2gl. Substitute all the values. The u is known to you, L is given. Calculate what is the actual friction. So now you see here the friction value is reduced to 0.16. But what is the design value? We have actually wanted to have for 100% brake efficiency, we required 0.7 friction value. But now in the actual condition, the friction value is at 0.156. So now how do you get the brake efficiency? The brake efficiency can be determined as the ratio between the friction that is developed divided by friction, design friction, multiplied by 100. So that is brake efficiency is given as 100 into f dash. F dash is the friction that is developed divided by f, the design value, multiplied by 100, because we are representing in terms of percentage. So that we can calculate, we'll got the friction value as 73.7%. That is the actual brake efficiency of the condition, existing condition. So now if you have the friction of 0.7, so you can see the brake efficiency will be 100%. Substitute if the what the design value and actual what it is developed, if these two are same, you will get the brake efficiency of 100%. But in actual condition, so this may not be true. The friction value will be always little less than the designed values. And we'll move on to the last numerical with this segment. So first, the data given is a vehicle was stopped in 1.4 second by fully jamming the brakes. So, and the skid marks measured was 7 meters. Determine the average skid resistance developed. So what the conditions are given, the time required to stop the vehicle is given, and also the skid marks, the length of skid mark is given. We have to determine average skid resistance developed. So what is the relationship we have? L is equal to u square divided by 2gf. This is a one formula. Another one is f is equal to a by g. So now to use the first formula, we don't have the speed value, and to use the second formula, we don't have the acceleration value. So now what we have to do is either we should determine the speed or the acceleration is need to be determined. So now we have the relationship. So when you take there are two relationships which will gives you the relationship between the speed, acceleration, and the time what is given to us. So those two relationships, first write down the data that is given. Braking duration is 1.4 second. Braking distance L is equal to 7 meters. So now the relationship which will gives you the the formulas which will gives you the relationship between the speed, acceleration, and time. It include V is equal to U plus AT. That's a first relationship. And so if you take the first relationship, we cannot calculate the acceleration. Both U, the spinal speed value is 0. The initial speed is also unknown, acceleration is also unknown. Yes, we cannot use this directly. But we have the one more relationship, v square minus u square is equal to 2as. So in this, we can establish s is equal to, s is nothing but the braking distance, u square divided by 2a. So with the previous equation, we have the relationship between the u and the acceleration. So now what value you have got in the equation 1, substitute here in the equation 2. So the replace from this equation, value of v square will be 0. So we will get s is equal to minus of u square divided by 2a. So why this minus? Because we are always, when the brakes are applied, it is not an acceleration, it is what we have is the deceleration of the vehicle. So anyways, the sign convention, don't bother about that. If plus will get during the acceleration and the minus taken as during the deceleration of the vehicle. So you can even neglect the sign considering that it is a deceleration of the vehicle. So now from the first equation we have u is equal to minus at square. So substitute in the second equation. Take this as the second equation. Substitute 1 in 2. So you'll get a square t square divided by 2a. So now here what are the known things? The s is known to us. T value is known to us. The only unknown is, so we'll get s is equal to a get cancelled, at divided by 2. So only s is known to you. S is nothing but the braking distance. S is equal to L is equal to braking distance. And the t is known, the unknown is the acceleration. So calculate what is the acceleration of the vehicle. So now so acceleration of the vehicles is taken as substituting value of s is equal to L is equal to 7 meter and t as 1.4 second. Will get acceleration as 2 into 7 divided by 1.4, that is equal to anyways you can directly substitute the relationship between the acceleration of the vehicle and frictional force. What we have is the F is equal to a by G. So substitute in that formula, so we will get what is the friction value, that is different. A value 2 into 7 divided by 1.4 square. I am directly taken that value and G value is 9.8. So we have got the friction developed. So with the these are the some of the examples which will show you how to determine the coefficient of friction considering the various data which has been given. So one thing is, remember we have just 4 set of relationship. Be thorough with that, and depending upon the what data is given to you, use the appropriate relationship to determine the average skid resistance developed by the pavement surface. Thank you everyone.